Welcome students in problem set part 2. Some examples we are going to take here. Students, welcome here in question number 7. See here, we are going to solve the quadratic equations. There are given some equations, we have to solve them. See here the first one, that is 1 upon x plus 5 is equal to 1 upon x square. That one we are going to solve. See here, I'll just go with cross multiplication because the both have in both the sides, that is monomial and numerator is 1. So just here what we'll get, that is x square is equal to x plus 5. Okay, now this all terms from this right hand side take to left hand side. That means x square minus x minus 5 is equal to 0. Now look here students, here this equation we cannot make any factorization. Why? Because just there's here the middle term has one only coefficient. Okay, and we need the product of two splitting terms is what? 5. That is not possible. So straightway we'll go with by using formula method. Okay, so we'll compare with the standard form, that is ax square plus bx plus c, which is equal to 0. By comparing, we can get here a is equal to 1, okay, b is equal to minus 1, and what about c? That is minus 5. And we know what we need first. We need first b square minus 4ac. Okay, see here, what is b square minus 4ac? We'll find here, that is minus 1 square minus 4 into a for 1 and c for minus 5. So here it is 1 minus minus plus 4 ones are 4, 4 5s are 20. This is what? 21. Okay, now the formula, that one already we know here. Okay, I'll write here this formula, that is very important one. Okay, see here, what is that? That is x equal to minus b plus or minus under root b square minus 4ac. Okay, that is very, very important. Okay, friends, this is really very important one. I'll write that one. Here it is b square minus 4ac upon 2a. Okay, in which we'll put the values here. Just see here, that is very important now. X is equal to minus b for minus 1, okay, plus or minus. What is that? B square minus 4ac, which is 21 upon 2a. A for again 1. Here it is 1 plus or minus root 21 upon 2. Okay, here that 21 we cannot make any factors here. That is 3 into 7. Both are prime numbers. So this is the answer. We can write here 1 plus root 21 upon 2 or x equal to 1 minus root 21 upon 2. Understand friends? Like this we can solve here. Okay. So now we'll take that second example. Just see here. This is very important one. Listen very carefully. So the second sum is, in the same example, second sum, that is x square minus 3x upon 10 minus 1 upon 10 is equal to 0. So this one we are going to solve now. Okay, just again very carefully we have to observe the equations. Okay, see here. First, we don't need that 10 in denominator. So straightway multiply to both sides by 10. What we'll get here now? Here it is 10x square minus 3x minus 1, which is equal to 0. Now just observe here. Here maybe factorization is possible. How? We need that sum is minus 3 we need here. And product is what? 10 ones are 10, that is minus 10. Okay, now just very carefully observe here, minus minus, we can get here minus plus, means difference should come 3, that is 5 2s are. It is correct? Yes, it is. That means we can split the middle term now. What we can get here now, that is 10x square minus 5x plus 2x minus 1 which is equal to 0. So from first two terms we can take 5x common. Yes, that is 5 2s are. One more time x is remains here. Now this whole 5x take common here. So we can write here just 1 only. Okay, plus. Now from these two terms we cannot take anything common here. So 1 will take common. That means just keep as it is both the terms. Means here this bracket we can take common. So what we can get here now? 2x minus 1. In second bracket 5x plus 1 is equal to 0. So when the two terms, the product is 0, we can write that first may be 0 or second may be 0. So in this way we are going to find the value of x now. So 2x equal to 1 means x equal to half. This side 5x equal to minus 1. So x equal to minus 1 by 5. Like this we can find the values of x. Okay, understand, it is depend upon example. If possible factorization, then solve by factorization, otherwise by formula method. Understand friends? Okay, now we'll take next third sum. Again it is very simple. See here the third sum from question number 7. What is that? Here in bracket 2x plus 3 bracket square is equal to 25. Let's see here now. This also it is very simple one. Just look here how we can simplify. Okay friends, look here. First it is very important is what? Because of the bracket square is there. Straight away we can make here square root to both sides. It is very simple, simplest procedure. Okay, taking square root to both sides. What you can get here now? See how simple it is. 2x plus 3 is equal to plus or minus 5. Finish. This is very simple. Here one different procedure is what? We can make here simplification by using a plus b bracket square. But here in both the sides just one term is there. That is why we can take square root to both sides. It is one of the very easiest example. Now we can write now 2x plus 3. 2x plus 3. Just wait. Okay. Now listen here. 2x plus 3 is equal to 5 or 2x plus 3 is equal to minus 5. Means now it is very simple to write now 5 minus 3. So in the next step 2x is equal to 2. So x is equal to 2 by 2 means x equal to 1. Now this side 2x equal to minus 5 minus 3. 2x equal to minus 8. So x is equal to minus 8 by 2. Means x equal to minus 4. Like this we can find the values of x here. Understand? This is one of the very easiest example. Now here if possible we can make here simplification also. First make the square root, that is a plus b bracket square, apply a square plus 2ab plus b square, or like this also we can solve. Understand friends? Now we'll take the fourth sum. See here the fourth sum. Look here, what is the fourth sum? Here m square plus 5m plus 5 is equal to 0. Now again just try to observe here whether it is factorizable. Yes, 5 ones are 5 means maybe here suppose 6 is there, then okay, or minus 4 is also okay, but it is not possible. Again I will make by using what? Using formula method. Okay, so straightway compare with standard form. What is the standard form here? That is, okay, I'll solve by just different color. Look here. Okay, compare with the standard form. That is am square plus bm plus c is equal to 0. So by comparing, a is equal to 1, b is equal to 5 and c is equal to again 5. So first of all we have to find b square minus 4ac. Okay, now find b square minus 4ac value. That is 5 square minus 4 into 1 into 5. Here it is 25 minus 4 5s are 20. That means only we'll get 5. As we know the formula, that is I'll write now variable is what? M. Okay, don't write now x here. Okay, M that is equal to minus b plus or minus under root b square minus 4ac upon 2a. Okay, now in this we'll put the values of a, b, c and that b square minus 4ac also. Okay friends, now what is that? Minus b, b for 5, already minus is there, plus or minus under root again 5. Okay, that is b square minus 4ac value. Okay, see here, this is b square minus 4ac value. We'll put up here. So 2 into a for 1 means what you can find now here? That is minus 5 plus or minus under root 5 upon 2. Finish. We cannot make anything here because that 5 has this perfect prime number. So keep as it is. That is the answer. That is what? Minus 5 plus under root 5 upon 2, or m is equal to minus 5 minus root 5 upon 2. Like this we can solve the example. Understand friends? Very similar. We can solve now remaining 2 sums also. And you can solve also. Okay, try to solve all these sums. Very easy, all these sums. See here now, fifth one. Look here. What is the fifth sum? Here it is. Fifth one is what? 5m square. Okay, plus 2m plus 1 is equal to 0. Now again, just try to observe here by using formula again, because it is not possible to make any factorization. Okay, we'll solve here. Okay, try to solve yourself also. It is also very important. Here, straightway write the standard form. That is am square plus bm plus c is equal to 0. Compare. A is equal to 5, b is equal to 2, c is equal to 1. Try to find the discriminant, which is b square minus 4ac, where b square is what? 2 square minus 4 into a for 5 into c for 1. Here it is 4. Okay, just look here, very simple and very important. Minus 4 5s are 20. Look here, it is minus 16, which is less than 0. Means we can write now, very important. See here, b square minus 4ac, which is less than 0. Means what you can write now? The given quadratic equations has not real root. Why? Because of this one. Okay, straightway write. Okay, no need to find that, use the formula. Don't make anything here. Why? If you put the value, suppose we'll put the value here, that is in this formula, which is our formula methods. Okay, here it is 2a, no? Now, if we'll put the value, what is b? B for 2 here, it is already minus. Here it is, this is what? What you can write? Minus 16 upon 2a. A for, that is 5. Look here, because of this is minus, we cannot find the root of any negative number. So it is not a real number. Okay, in further studies that will come like it is called as imaginary number. But now in this 10th standard it is not in our syllabus. So we cannot find the roots here because the roots are not real. Understand? Like this we can solve this example. Okay friends, now we'll take the next, which is the last example of this question. Let's solve. See here the sixth sum. See here, what is the sixth sum? Here it is x square minus 4x minus 3 is equal to 0. Again, just try to observe here whether it is possible to make any factorization. I think yes it is. See how can solve this one? Just listen. Sum minus 4. Okay, product we can find here now minus 3. Product 3, when it is possible, 3 ones are. Okay, so we'll write here minus 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 plus we can find. Okay, just check whether it is possible or not. Okay, 3 means what? 3 ones are. Understand? Now their difference is what? Minus 2 only. But we have what? Minus 4. That means the factorization is not possible. So again go with by formula method. So we'll solve now here. That is ax square minus bx plus c is equal to 0. So by comparing, a is equal to 1, b is equal to minus 4 and c is equal to minus 3. So try to find the value of b square minus 4ac as usual. That is minus 4 square minus 4 into a for 1 and c for minus 3. That means here it is 16 minus minus plus 4 ones are 4, 4 threes are 12. Here it is what? 28. Okay, now as we know the formula is what? Here variable is what? X. So x is equal to minus b plus or minus under root b square minus 4ac upon 2a, in which we have to put the values here. Okay, see here minus b for minus 4 plus or minus under root what? That is 28. Okay, upon 2a, a for 1. Now just listen very carefully. That is minus minus plus. Here it is plus or minus. Now this 28, see here, that is nothing but 4 into 7. We can take this 4 outside, means root of this 4 is what? 2. That means what we can write here now? 2 root 7 upon 2. Most number of students make some mistake here. 2 ones are, 2 twos are, like this makes mistake here. So don't make these kinds of mistake. We'll take common from numerator. That is 2 we can take common. So 2 twos are, means here it is only root 7 remains. Now denominator is 2. Now this one getting cancelled. So the answer is 2 plus or minus root 7. Now the roots are x is equal to 2 plus root 7 or x equal to 2 minus root 7. Like this we can solve the sums, which are very very simple and important. Understand friends? Okay. Friends, in question number 8 here, just see here, find m. We have to find the value of m here. Okay. Now they're given to us one quadratic equation, that is m minus 12 x square plus 2 into m minus 12 into x plus 2 equal to 0 has real and equal roots. Okay, already we know real and equal roots means what? There should be b square minus 4ac is what? 0. Okay friends, now see here, I will take first quadratic equation as it is, that is m minus 12 into x square plus 2 into m minus 12 x plus 2 equal to 0. Already it is in standard form. Okay, we'll compare with the standard form. That is what? Here ax square plus bx plus c is equal to 0. Now see a for, here it is m minus 12. Okay, and b for 2 into m minus 12. And what about c? That is 2. We are going to find the value of b square minus 4ac. What about b? That is 2 into m minus 12 bracket square. Okay friends. Now minus 4a, that is m minus 12 plus c, that is 2. Okay friends. Now look here. It is very very important part here. So we can make here, this is nothing but 4, that is m minus 12 bracket square. Okay, see here, here it is what? Here into c, sorry, this is into c. Okay, 4 twos are 8 here. Okay, 8m minus minus plus 12 8s are 96 here. Okay friends, now look here, this is the way. Now just try to observe here. This given equation has real and equal roots. This one keep as it is. Okay friends. But the given quadratic equation has real and equal roots. Okay. Means what? Their b square minus 4ac equal to 0. Therefore, this value means 4 into m minus 12 bracket square minus 8m plus 96 is also equal to 0. Now, very important part is what? Divide to both sides by 4 here. Let's see here. Now what we can make here now? M minus 12 bracket square. Now here divide, that is minus 2m plus 96 divided by 4, which is 24 here. Okay. Now I'll expand this one. What will get here? This is m square minus 24m plus 144. Here it is minus 2m plus 24 equal to 0. So the next part is what? Write m square minus, this is m term and here also m term, which is minus 26m. Here 144 plus 24, that is plus 168 is equal to 0. Now factors. That is very, very important. If you observe here, 168 here, I think if you will make anything splitting here, we can find now. This is very, very important. If you observe here, we can find that is 14 and 12 we can find. Okay. So here minus 26, no. So we are going to make that splitting, that is minus 14 and minus 12. So their product we can find, that is 168 here. Okay. So because of here 1 is there, we can write directly, that is m minus 14 and here m minus 12 is equal to 0. Now m minus 14 equal to 0, m minus 12 equal to 0. So m is equal to 14 and here m is equal to 12. But just try to observe here. If we'll take this m is equal to 12 and we'll put the value here, then here becomes 0. If here this term is 0, then this is not a quadratic equation. Hence, m is equal to 12 is not considerable. Understand friends, why it is not considerable? Try to write here. If we put m equal to 12, then the given equation is not a quadratic. Therefore, m is equal to 12 is not considerable. Therefore, write m is equal to 14. Understand friends? Like this, we can solve the sum. Okay? See friends, in ninth sum, the sum of two roots of a quadratic equation is 5. Sum of two roots means what? Alpha plus beta is 5. And sum of their cubes is given to us, which is 35. Okay? Means we are going to find the quadratic equation. This is one of the very important sum. Okay friends? This is really very, very important. We'll find first. So, how to solve? Let alpha and beta are the two roots of required quadratic equation. This is very important. What they are given to us? Alpha plus beta is given, which is 5, and sum of their cubes also given, that is alpha cube plus beta cube is equal to 35. To find quadratic equation, we need alpha plus beta. We have that one. Now we need what? Very important is what? Alpha into beta we need here. So from these two, we know one equation. That is one formula we can write here. That is alpha cube plus beta cube, which is equal to alpha plus beta bracket cube. But in this part, there is one minus 3 alpha beta into alpha plus beta is extra. That one we don't need here. So write minus 3 alpha beta into alpha plus beta. This is one of the very important part. Just try to remember. Okay, now see here it is very important part is what? This is 35. Look here. This is very important part. This is what? 35. Okay. What is alpha plus beta? Which is 5 cube minus 3 into alpha beta we don't know into this alpha plus beta also again 5. Now just try to simplify here. This is 35. 5 cube, it is 125 minus 15 into alpha beta. So take this to this side. So 15 alpha beta is equal to 125 minus 35. Therefore, 15 alpha beta is equal to what? 90. Therefore, alpha beta is equal to 90 upon 15. Means what? Alpha is equal to 6. Okay? But we know that. What we know? Sorry, here it is alpha into beta is there. Okay? See here. This is what? Alpha into beta. Okay, friends? Now, just look here. But we know that. What we know? That equation which is x square minus alpha plus beta into x plus alpha into beta equal to 0. We'll just put the values here. That is x square minus. What is alpha plus beta? Which is 5 and into x plus alpha into beta. Just we find that is 6 is equal to 0. This is the required equation. Understand, friends? Like this we have to solve. Okay, friends? Friends, in the 10th example, the example is find a quadratic equation such that its roots are square of the sum of the roots and square of difference of the roots of equation 2x square plus 2 into p plus q into x plus p square plus q square is equal to 0. So from this information we are going to find one required quadratic equation. Okay, let's solve. See first. First of all, I'll write the given equation as it is. Okay, that is nothing but 2x square plus 2 into p plus q x plus p square plus q square is equal to 0. Okay, friends. Now this equation which is in the form of ax square plus bx plus c is equal to 0. Now if we'll compare these two equations, then we can find the value of a which is equal to 2, b twice of p plus q. Okay, and what about c? That is c is nothing but p square plus q square. Okay, now what they are given to us? First of all, we have to find alpha plus beta. Okay, because alpha plus beta, alpha and beta are the roots of this equation. And now we are going to find one new equation having roots are alpha 1 and beta 1. That we'll discuss afterwards. First of all, we have to find alpha plus beta. Okay, see here. Alpha plus beta. What is alpha plus beta? We know already. That is minus b upon a. Okay, we'll put the value. What is b? Twice of p plus q. Okay, upon a for 2. So these 2 getting cancelled. What will get? Minus p plus q. Okay. Now afterwards I'll find here now alpha into beta as well. So what is alpha into beta? That is nothing but c upon a. Okay, what is C here? P square plus Q square upon A for 2. Like this, we'll find alpha plus beta and alpha into beta. Okay, now let alpha 1 and beta 1 are the roots of required quadratic equation. Required quadratic equation which we are going to find. Okay, now look here. That is very important part is what? First of all, alpha 1. What is that? They are given to us. Okay, sum of roots of this, the given equation, their square. Okay, the given to us what? I'll read again the question. Find the quadratic equation such that its roots are square of sum of the roots. Square of the sum of the roots means what here? First one is what? Alpha 1 is nothing but square of sum of the roots. Okay, and I'll put the value here now. Look here. What is that? Square of minus P plus Q, and we have to write here square. Okay, so that means what? Square of this minus is nothing but plus. So straightway we'll write here P plus Q bracket square. This much only. Okay friends. Now second root, that is beta 1. What is that? Difference of roots of the given quadratic equation, its square. Means what? We'll write here now alpha minus beta. Okay, bracket square. Okay friends. Now, but we don't know alpha minus beta. Okay, that is why our reform of that one is nothing but I'll write in this form alpha plus beta bracket square. Here plus 2 alpha beta is there. Okay, and here minus 2 alpha beta. So for that reason, if I'll make here minus 4 alpha beta, then that will come, it is equal to alpha minus beta bracket square. Okay friends, try to check whether it is correct or not. Okay, now I'll put the values here. What is alpha plus beta here? That is nothing but, already we find here, minus P plus Q here. Okay, so here it is minus P plus Q, and here because of the square, we'll write like this one. Okay, minus 4 into, what is alpha into beta? Here it is P square plus Q square upon 2. Okay, P square plus Q square upon 2. Okay friends, now look here, the very important part here, just try to make the simplification. After that we'll write here now. Okay, see here, in the next step we'll write here. What we'll get here now? See here, minus square, here square of this minus is nothing but plus, so it is nearly P plus Q bracket square. We know that expansion. What is that? P square plus 2PQ plus Q square. Okay, now here by cancellation here we'll get only 2 here, but that is minus 2. Okay, in the next bracket we'll write here, that is P square plus Q square. Okay, so what we can write here now? Here only I will write here. Okay, see here, what we'll get here? P square plus 2PQ plus Q square minus 2P square minus 2Q square. So in all we'll get here what? That is nothing but, that is P square minus 2P square minus P square. Okay, middle one plus 2PQ, and here plus Q square minus Q square, that is minus Q square. So if we take minus sign common, we can get here P square minus 2PQ plus Q square. That is why we can write here minus P minus Q bracket square, which is nothing but beta 1. Second root. Okay, now after getting alpha 1 and beta 1, to frame the equation, what we need? The sum and product. So let's find here alpha 1 plus beta 1. What is alpha 1? See here. This is P plus Q bracket square. Plus, what about beta 1? That is here minus P minus Q square. This is beta 1. Okay. After simplification, see here, what we'll get here? This is expansion P square plus 2PQ plus Q square. And here square of minus, okay, keep this plus minus minus. Okay, write in bracket only. Yeah? That is nothing but P square minus 2PQ plus Q square. Okay, in the next step, we'll write here that is P square plus 2PQ plus Q square, sign change, minus P square plus 2PQ minus Q square. So here this P square getting cancelled. Okay, see here. This P square and P square getting cancelled and Q square also getting cancelled. So what remains here? This is nothing but 4PQ. This is alpha 1 plus beta 1. Okay. Now similarly, we'll find now alpha 1 into beta 1. What is alpha 1? This is here. That is P plus Q bracket square into. What about beta 1? That is nothing but, here it is. That is nothing but what? Minus P minus Q square. This is beta 1. Okay. Now just see here. I'll write this minus sign before this one. Okay. Now in the next bracket, we'll write here P plus Q and into P minus Q. Both having squares here. So I'll write here bracket square. Means what we'll get here? Minus in bracket P square minus Q square. But remember here it is square. Okay, this is what alpha 1 into beta 1. And we know the quadratic equation. What is that? That is nothing but x square minus in bracket alpha 1 plus beta 1 x plus alpha 1 into beta 1, which is equal to 0. This is the required quadratic equation of frame of that one. We'll put the values here. That is x square minus. What is alpha 1 plus beta 1? That is 4PQ. Okay. We'll write 4PQ x plus. What about alpha 1 into beta 1? This is minus. Okay. Minus P square minus Q square bracket square. And this is because of this minus, we'll write this square bracket. Therefore, the next step, which is the last one, which is x square minus 4PQX plus minus minus in bracket P square minus Q square bracket square is equal to 0 is the required quadratic equation. Okay friends, like this we have to solve. This is one of the very important example. Okay.